Today I'm detailing how to cut a curved slot. So here's the locations of where this slot is. The center right here at the end is 564.9x, y 779.5. Down here, x 582.2, y 703.5. And that gives us a radius of 16.5 millimeters. The arc on the left side here is 589.4 and 622.4. So in this demonstration we're doing it without cutter comp. So what I did is I wrote, I sketched out the slot and I wrote down each step that the cutter is going to be moving in, so I can determine what's going on here. So I also detailed a little bit of what G2 and G3 is. I can add on here G1. G1 is just a linear move. Okay, so G2, the cutter is going to be moving in a clockwise movement. So this here really is kind of showing what that means. So here the cutter is moving along here clockwise. Then it all of a sudden goes counterclockwise, G3. Still stays G3, G3, and then when it comes out of the cut, G1. And so I've got that all detailed here. What is the G? G1, G2, G3, and so on. So what are the X's, the Y's? Now, if you have a G2 or a G3, you need to define what the R is. So since we don't have cutter comp, we need to add the radius of the tool on this side. So here's your basic, X plus or X minus. So we need to move the cutter, the radius of the cutter that way. So we need to add to 601.725. So this arc will be correct. On this side, 622.4, we need to subtract. So here's where the cutter would be if you didn't do that. We need to subtract over that 622.4 to 610.075, so that it will cut where it needs to be. So with the cutter radius is 12.325. I subtracted the radius of the slot, which is 16.5, from the radius of the cutter, and that gives us 4.175. So I added and subtracted the radius of this cutter to the slot arc, which I just mentioned. We already talked a little bit about this G1, G2, or G3. That's already been done for us. Notice the feed rates are changing, so you can come into the ends of this slot are already drilled. I drilled it a little bit bigger than the end mill size, so the end mill's coming right in at a pretty fast rate. It goes linearly into step 2, G1 linear, and that 560.725. So it was at 564.9. And if you subtract the cutter radius, the radius of the cutter from this 16.5, the radius of the slot, you get 4.175. So 564.9 here minus 4.175 equals 560.725. The Y doesn't change because it's just a 9 o'clock straight move. F200, that's millimeters per minute. Now we're going into a clockwise G2 move here, down into step 3 at the 9 o'clock position of the bottom of the slot down there. And so how did we determine that? Well, we got 582.2 in the X. So again, this is 16.5 slot radius. You subtract off from that 16.5 the radius of the cutter. Again, you get that 4.175. So that's number 3. So 582.2 subtracted from 4.175, 578.025, 9 o'clock. So 9 o'clock is going to give us a straight 703.5. And now, we have a G2 move, so we need to tell it what the R is. So, and that's 601.725. The print showed 589.4, but we need to move the radius of the cutter over. That gives us 601.725. Number 4, that's a G3 move, counterclockwise. So we need to tell the machine that. Now, we're at 586.375. So it's 582.2 plus 4.175. That gives us the X for number 4. Y stays the same. Radius. What is the center of this arc here? This move from 9 o'clock to 3 o'clock? It's 4.175. So actually, if you multiply that by 2, 4.175 by 2, you should get this X change here. So 586.375 to 569.075. Excuse me, it should equal that. So if it doesn't equal it, your machine will probably alarm out. Now number 5 up here. So we've got an R of 622.4. We want to subtract off that 12.325. So we get R 610.075, which I have that there. Notice I've got a higher feed rate here. Most of the slot is already cut out from 0.2 to 0.3. So it's buzzing along quicker. All right. 779.5 is just straight because it's at the 3 o'clock position. How did I get that? 564.9. Again, same thing. 16.5 slot radius minus the radius of the cutter, 4.175. So 586.375. Oh, sorry, we're up here. For number 5, 564.9 plus 4.175. And that gives us number 5. 6. Got the feed rate cut down. Feed rate would be significantly higher if the drill I used was the same size as the end of this slot, but it isn't, so this actually moves along pretty fast getting to this side of the slot. So I've got that back down to feed rate of 60 millimeters per minute. So there we are on 6, which is almost the end of the slot there. It's finishing up its cut at the 9 o'clock position. 564.9 minus 4.175 for number 6 is the 560.725. It's a G3 move again, counterclockwise. And then now we're coming out of the cut, G1, right over into the last one of 7, which is the same as number 1, 564.9. It's the same move there. Coming out of the cut, we don't need to come out slow, so 2,000. And now you either go down to your next cut depth or come out of the slot. So that's in a nutshell how I made this curved slot without cutter comp. I hope you enjoyed my video. I hope it was helpful for you. If you have any questions, definitely fire away at me, and I hope I can help you. If you like this video, please give me a thumbs up.